Hello friends, today we will discuss design of cold mix for bituminous concrete as given in MRTH specification 2013 and the procedure is given in MS-14. This bituminous cold mix is one where you do not heat the aggregate or bitumen and it can be provided either with the emulsion or with the cutback. But today we will discuss how to design a mix for bituminous concrete using emulsified bitumen or simply bitumen emulsion. Now this bituminous concrete can be laid in the thickness of 25 to 75 millimeter as per MORTH specifications, and gradings are specified for different thicknesses.
So this is a mixture of coarse aggregate, fine aggregate, filler, water and bitumen emulsion. Coarse aggregate will be crushed rock, crushed gravel retained on 2.36 mm sieve, and they should be as usual clean, hard, durable and of cubical shape, free from dust and of low porosity. The requirement of filler, that is material passing 75 micron sieve in cold mix bituminous concrete, should be made from stone dust, cement or lime or any other non-plastic mineral material. And this is the list of property of coarse aggregate that should be met in the field. Cleanness measured as passing 75 micron sieve should be less than 5. Flakiness elongation index combined less than 35%. Abrasion test or impact value, then soundness test. Water absorption, that is the measure of porosity, should be less than 2%. Stripping, that is coating test, 95% minimum. And water sensitivity test, that is retained tensile strength, should be 80%. The fine aggregate, crushed or naturally occurring mineral materials passing 2.36 millimeter and retained on 75 micron sieve, and natural sand is not permitted in BC layer. The filler is either rock dust or lime having the grain size distribution as given here. It should pass 100% through 600 micron sieve and 85% to 100% on 75 micron sieve. Grading of aggregate depends upon layer thickness, and as per IRC and MORTH, the BC layer can be laid in a thickness of 25 to 35 millimeter or 36 to 50 or up to 75 millimeter. And accordingly, nominal maximum aggregate size is specified. And these are the grading to be met at site. Before designing the mix, it is important to test aggregate and binder, and the aggregate should be proportioned in a definite percentage to get the desired grading. And there are several methods to apportion the aggregates, and I have discussed these three methods: trial and error method, analytical method and graphical method in my earlier video. You can watch them. You can use any of these methods to mix the aggregates which are available at site to get the desired grading. The job mix formula to be prepared is given in MS-14 Appendix F.
Design procedure or preparation of job mix formula for cold mix is a 4-step process. One is determination of pre-mixing water content, that we call the coating test. Second is determination of optimum water content at compaction, how much fluid is required to achieve the maximum density. And third step is determination of residual asphalt content, optimum residual asphalt content. And then after that you carry out the density and wires analysis to determine the optimum emulsion content in the mixture. And to carry out this coating test, the first of all we should determine how much bitumen emulsion to be added. MS-14, Appendix F of MS-14 suggests an equation to determine the approximate amount of bitumen emulsion. And this equation is like this, that percentage of emulsion by weight of dry aggregate is given by this equation: 0.7 times 0.05 into A plus 0.1 B plus 0.5 C. Here A is the aggregate retained on 2.36 millimeter sieve, percent aggregate, by weight of total aggregate. B is passing 2.36 millimeter and retained on 75 micron or 90 micron. And C is the percent passing 75 micron sieve size. So if you consider the grading for 30 millimeter bituminous concrete as suggested in Morth Specification 2013, then this A value, which is the aggregate retained on 2.36, will be 50%, B value will be 50 minus 6, that is 44, and C is 6. And with these values, if you calculate the percentage of emulsion in the aggregate mass, it will be 6.97%. What the code suggests that it should be taken in the whole number, and therefore let us say 7%. Now, this is the approximate quantity of bitumen emulsion to be added when you are conducting the coating test.
Dry the aggregate in the air so that each size is easily separable. Particularly fine material passing 4.75 millimeter should have free flowing. Determine the moisture content of air dried aggregate. Take 1200 gram of air dried aggregate as per grading of the mix. For example, BC in this case. Place the aggregate in a bowl and add predetermined percentage of water. This water is taken as percentage of dry weight of aggregate, but it is added in excess of the air dried aggregate. For example, if the intention is to add 3% water by weight of dry aggregate, but aggregates are moist and have the water content of 0.4%, then only 2.6 water by weight of moist aggregate is to be added. Or simply take oven dried aggregate and add 3% water to it. Water should be added very slowly to disperse it thoroughly. Around 1 minute time is good enough for mixing. Now add the amount of emulsified asphalt as determined from equation, 7% in this case. Again, mix it properly, and here also 1 minute mixing time is sufficient. Now this is the mixture at 2% water content. Similarly, you prepare the mixture at 3% water content and 4% water content, but the amount of emulsion will remain same, that is 7% by weight of aggregate. This one is at 2%, this is at 3%. Now this is the sample prepared at 4% of water content. Now these are three samples at 2%, at 3% and at 4%. Allow the sample to dry in air or under the fan for 18 hours. And after 18 hours, you just visually see them for the coating of aggregate by the emulsion. Now, aggregate coating in excess of 50% is acceptable. And here in this case, if you look at this sample at 3% water content, you find that the coating is more than 50%. Now in case of 2%, there is no coating at all. In case of 3%, it is more than 50%. You can see it. Now this mixture is completely white at 2% water content, and the third one at 4%, it is much more than 50%. So by this test, you determine what is the amount of water required for coating. So here 3% water content is sufficient to have coating of 50%.
Now, the optimum water content according to coating test is, or you can say minimum water content required for coating test is, in our case, 3%. Now the next step is to determine the optimum water content at compaction. Now Marshall specimen is used to determine the level of compaction here, and these Marshall specimens are prepared using the same amount of emulsion, that is 7%, but now the water content is varied. And if you, let us say, consider X% water content you obtain from coating test, then you prepare the specimen at X minus 1, X plus 1 and X plus 2 water content. So in this case, in our case, we got 3% water content required for coating test. So we will prepare the Marshall specimen at 2%, 3%, 4%, 5% water. And normal procedure is used to prepare the Marshall specimen of a standard size. Only difference is here that we don't heat the aggregate. We do not heat the aggregate or emulsion. The aggregates are kept at a temperature of 22.2 degrees centigrade and the mix is prepared at room temperature.
So take 1200 gram of oven dried aggregate. The temperature of aggregate should be 22.2 degrees centigrade. Add water to it and mix it properly. If the water content is kept 3%, then 36 gram of water is to be added, and temperature of water should also be around 22.2 degrees centigrade. After that, add bitumen emulsion as we have done in the case of coating test. For 7% bitumen emulsion, take 84 gram of emulsion and add slowly and mix it properly, and here also 1 minute mixing is sufficient. Now place the mold, clean the mold, oil its surface and place it on the base plate. Put a filter paper at the bottom of the mold and place mixture into the mold and tamp the mixture with a small rod or spatula 15 times around the perimeter and approximately 10 times over the interior surface. Now you place the second filter or waxed paper over the top of the mixture. Place the mold assembly at the compaction pedestal and apply 50 blows with Marshall compaction hammer. After 50 blows, remove the collar and base plate. Reverse the mold and reassemble. Apply 50 blows on the second phase also. And after that, you cure the specimen in the mold for 1 day at room temperature and then extrude. After extruding from the mold, determine the bulk specific gravity of the specimen by taking the weight of the mold in air and in water as per ASTM D1188 or D2726. After taking weight in the water, just make the surface dry and take the weight of the specimen again in the air. That is your weight of SST sample in air.
Once you get the weight of the sample in air and in water and also in SSD condition, you can calculate the bulk density and dry density of the mixture. Now bulk density specimen, let us say G, is weight of a specimen in air divided by weight in SSD condition in air. SSD is surface dry but saturated condition of the specimen minus weight in water. So in our case, this weight in air is 1211 gram. Weight in SSD condition is 1217 gram. And this weight is 636.5 gram. If you put values, you get the density 2.086 gram per centimeter cube. That is the bulk density. Now, dry density GD is given by this equation, that G is to be multiplied by a factor 100 plus A upon 100 plus A plus K. Now here A is the amount of bitumen in the emulsion. So if you are taking, let us say 7% bitumen, 7% emulsion in your mixture, and assume that it contains 65% bitumen, so this 65% of 7% will be 4.55%, and that is your value of A. And K is the moisture at compaction. Now this is determined from these two weights. So this is mass of water in the sample, K. K is mass of water in the sample divided by mass of dry mix multiplied by 100 plus A. So mass of water here is 1217 minus 1211, that is 6 grams. And mass of dry mix is 1211 multiplied by 100 plus A, so 104.55. Now this is equal to 0.518. Put these values here. G you know 2.086, A is now 4.55, K is 0.518. So the dry density will be 2.076. Similarly, you prepare a specimen at different water content, find out the dry density in each case, and then make a plot between the dry density and moisture content, taking GD here on the y-axis and water content on x-axis. You get this kind of curve. Find out the optimum water content corresponding to maximum dry density. Now this is the water content which is required for next step. Now the third step is to determine the optimum residual asphalt content, residual bitumen content. So in the second step, we got the optimum fluid content. We added 7% bitumen emulsion and we got, let us say, 4% water to be added as per total optimum water content required from compaction test. Now OFC, or optimum fluid content, is now 7% emulsion plus 4% water. This we assumed as per equation given by MS-14, and this you got from the compaction test. Now this 7% emulsion also contains 35% of water. So it is 35% water means 2.45%. So this water content is already there in the emulsion. So the total water content required in the mix 4 plus 2.45, that is 6.45. Now that is to be kept constant in all specimens, in all set of specimens, that the total water quantity should be 6.4%. Now this test or this step is carried out at varying proportion of emulsion. So if you consider, let us say, emulsion 6% by weight of aggregate, water will be 6.45%, and water in the emulsion 35% of 6, that is 2.1%, and therefore extra water to be added is 6.45 minus 2.1, that is 4.35%. So quantity of water is now 4.35 multiplied by 12, because you are taking 1200 grams of the dry aggregate for Marshall specimen, that will be 52.2 gram. Emulsion is 6%, so 6% of 1200, that is 72 gram. That makes one set of a specimen. If now you change 7%, this remains same, 6.45. In the 7%, you have now 2.45 water content, 35% of 7%. And therefore, you add 4% water to keep 6.45. So 4% means 48 gram, and this will be 84 gram. Similarly, you prepare 2 more rows here for 8%, for 9%. Remember that the water content should be 6.45%. Now prepare the partial specimen as we do in a normal case. Take 1200 grams of dry aggregate and add water, 52.2 gram of water at 22.2 degrees centigrade. Mix it properly as we have done in case of compaction test, and then add emulsion in a very thin layer and mix it properly so that you get a uniform mix. Compact it with the 50 blows of the Marshall hammer on each face, and after that, then you cure the specimen in the mold itself for 1 day at room temperature, and then extrude the sample from the mold, keep it at 38 degrees centigrade for another 1 day. Now for each content of the emulsion, we prepare 6 specimen, 6 Marshall specimen. 3 specimen are tested under unconditioned conditions, and 3 specimens are tested under conditioned specimen. So if you are considering 6, 7, 8, 9% of bitumen emulsion, you need to prepare 24 Marshall specimens. Now for unconditioned test, or you can say dry stability test, after curing at 38 degrees centigrade for 1 day, you carry out the Marshall test and find out the stability and flow value of the specimen. Take average of 3. That is the stability under dry conditions or unconditioned sample. Second set of specimen is kept for vacuum saturation in a desiccator at 22.2 degrees centigrade, applying a vacuum pressure of 100 millimeter of mercury for 1 hour. And after 1 hour, you release the pressure slowly and keep the sample in water for another 1 hour, the same desiccator. Now you test these specimen for Marshall stability. So that is the stability under conditioned condition, or you can say wet stability. Now the stability ratio or loss in stability is the ratio of these two values. Retained stability is average stability of wet sample divided by average stability of dry sample. Now here average, basically average of 3 specimens. What the MORTH specification suggests that this loss in stability should not be more than 50%. So you should get this value higher than 50%. Now once you complete the testing of all specimens, then the last step is to carry out density and wires analysis. Now here, total wires in the mix V is equal to 100 plus A plus K upon G minus 100 upon C minus A upon B divided by 100 plus A plus K upon G. A is the asphalt residue in the emulsion, 65%. Okay. K is the again moisture content at the compaction. But here the determination of moisture content at compaction is slightly different. Now after you carry out a stability test on the Marshall specimen, you break this specimen completely in small pieces and put in the tray. Now this tray or this specimen is now kept in the oven at 93 degrees centigrade for 24 hours. After 24 hours, you take weight of the specimen, weight of the sample in the tray, and then find out the mass of the water by this equation. Weight of original sample minus oven dried weight minus, let me put F minus D. Now this F is weight of saturated surface dry specimen in air, and D is the weight of sample which was extruded from the Marshall mold. Now this weight of original sample is after testing of the sample for stability, and this is the oven dried which you have broken into pieces and kept in the oven for 1 day at 93 degrees centigrade. So you calculate mass of water by this equation, and then let us say this is W, then K, let me call it K2 just to avoid confusion from the earlier equation. K2 is now WW upon oven dried weight of the broken sample. That is your K2. So let me put here K2. And A is the asphalt residue in percent by weight of dry aggregate. K2 you have calculated. C is the apparent specific gravity of aggregate, and B is the specific gravity of asphalt residue in the emulsion, and G is the bulk specific gravity of the specimen. Now air wires are calculated. That is, let us say V is equal to V minus 100 K upon 100 plus A plus K divided by G. Another parameter required for the mixed design is the VMA. 100 plus A plus K upon G minus 100 upon C divided by 100 plus A plus K divided by G. These parameters are to be calculated for each bitumen emulsion content, and then you make the plots. Normally 3 plots are sufficient. In this case, residue content, and this is stability. And this will be like this for wet stability, and maybe like this for dry stability. So dry stability will consistently reduce with the emulsion content. Another one is between dry density and GD and bitumen residue, and third will be with the air wires. The specification suggests that the air wires in the mixture should be 3 to 5%. So as we normally do in a design of mix, you take corresponding to 4% air wires, find out what is the optimum residual bitumen quantity, and then check for the stability. Now, stability should be at least 2.2 kilonewton at 22.2 degrees centigrade. So that is the highest value here. You can just make some adjustment between the air wires because the range of air wires is 3 to 5%, so that you get as close to maximum density as possible. So that is how you design the mix. Requirement of VMA depends upon the grain size, nominal maximum aggregate size, and it is 16%, minimum 16% for a NMS of 9.5 millimeter. So that is the complete procedure of designing a cold mix for bituminous concrete. Thank you very much for watching this video. If you have any questions, you can write.